Hi group, James here in chapter 5 and we're talking about a correlation matrix. So if we have two sets of data, we can compute a correlation coefficient for that's looking at the relationship between the input variable and the response variable, or the predictor variable and the response variable. And I just want to underscore that there are times where we have to make that choice in our field of work as far as which variable makes sense as the predictor and which variable makes sense as the response. Again, we're being very careful not to describe this in terms of causation, but we are using the term correlation. So we're looking at patterns between two or more variables. So if we have more than two variables that are linked to the same individuals, as we have here, suppose that these are 3 tests that students in a class took, what we may do is ask the question, do the results from one test predict the results from the other tests, and vice versa? So Microsoft Excel and Google Sheets allows us to very easily, very quickly compute all of the possible correlation coefficients for multiple sets of data. And that's where we get this correlation matrix. So if I'm looking at these data, I could look at correlations between test 1 and test 2. That would be one correlation coefficient. I could look at a correlation between test 2 and test 3. And lastly, I could look at test 1 and test 3 and compute correlation coefficient. What statistical software allows us to do is to compute them all at once and look at a matrix of values. So I have all my data selected for these 3 tests for a course. My input range is just exactly that, A1 to C21. I'll delete this out so that I can show how this is populated again. A1 to C21. Again, our data is grouped by columns because test 1 is its own set, test 2 is its own set, test 3 is its own set. We do have our labels in the first row, and output range of E1 is okay. So we're going to populate this matrix. Okay, I'm going to undo that. I don't want my output range here. I want it in E1. So I need to click back over here in Google Sheets so that it says E1 for our output range. And now we need to do a little bit of explaining. Again, these are all Pearson correlation coefficients. You'll see the value of 1 along the diagonal in this matrix. And that's really trivial because what we're asking is what's the correlation between test 1 and test 1? Well, it's the same exact data. So it's going to have a perfectly positive correlation. And the correlation between test 2 and test 2 is, of course, trivially perfect. And the correlation between test 3 and test 3 is also trivially perfect. Now we have the 3 pieces of correlation statistics for the 3 sets of data. If I use test 2 and test 1, the correlation coefficient is 0.0557, which is very weak positive correlation. If I look at a correlation between test 3 and test 1, it's 0.15, which is also positive and very weak. Lastly, if I look at the correlation between test 3 and test 2, it gives us a correlation coefficient of negative 0.391, so forth. Again, now in this case, it's negative, and the 0.38 from the textbook on page 88, 0.38 would be weak, a weak relationship. The other two would fall as weak or no relationship. So slightly stronger in the third correlation coefficient. And I'm just going to highlight this here, test 2 and test 3. If I wanted to do these on their own, I could do that. And it gives us the same exact value. I'm just underscoring that it's the same value. This actually gives us a matrix for just these two values. So I just wanted to show that these are Pearson correlation coefficients. Now our textbook actually fills in these values as well. And what I would like you to do is to take a moment and see if you can explain to yourself, or if you can explain to somebody in class, how these remaining values are filled in. So take 30 seconds or a minute and see if you can explain how these three values are generated in the correlation matrix. Go ahead and pause your video now. Using the honor system, I'm curious as to how many of you paused the video. This matrix has symmetry to it. And what I mean by that is if we look at a relationship between test 1 and test 2, well, that's actually the same as looking at test 1 and test 2. And really the question is which are we using as our predictor? And the fact that we have the symmetry in the matrix tells us that regardless of which one's our predictor and which one is our response, the correlation coefficient is the same. And from a conceptual standpoint, that makes sense because we're looking at a relationship between the same two variables. So the order, or which one we use as a predictor, doesn't matter in terms of the correlation coefficient, but it does matter in terms of what we're trying to describe. So again, as we're working in our field of work, we have to make that choice between predictor and response. So if I'm looking at the relationship between test 3 and test 1, well, that's really the same as looking at the relationship between test 1 and test 3. And likewise, this relationship between test 3 and test 2 is the same as looking at the relationship between test 2 and test 3. So that's the reason why in the textbook you'll see that there is this symmetry along the diagonal. Again, the values in the diagonal are 1, very trivially. And then if we look at corresponding locations, they have the same correlation coefficient. And that is our correlation coefficient matrix.